Okay, so the velocity time graph that you have to sketch will look like this. So initially the train is at rest here, and then we have constant acceleration, which is represented by the gradient of this line, constant gradient, and then in this region the train is travelling at its maximum speed. Okay, that's the maximum speed in this portion here. And then the train decelerates and comes to a rest. The total time for the journey is 84 seconds, but we don't know what these values are. We don't know the time here or the time here. We do know that the area under the graph, the area under a velocity time graph, gives the displacement. So the displacement, or the distance between the two stations, is 960. This shape is a trapezium, so I can write down the area for this shape using the formula for the area for trapezium. So the area is equal to half times 15 multiplied by, and now I have to add the lengths of the two parallel sides, these two sides. So from here to here is T2 minus T1 plus, and from here to here is 84. And to work out for how many seconds the train is travelling at its maximum speed, there's the maximum speed part of the graph, which is this, T2 minus T1. So we need to rearrange this to work out the value of T2 minus T1. So 44 seconds. The train accelerates at 0.5 meters per second squared, so that's the gradient of this line here. So we can work out the value of T1 now. Suvat formula, substitute the values in, so T1 is equal to 30. So from before we know that T2 minus T1 is 44 seconds and T1 is 30, so T2 is 74 seconds. So by using the coordinates for these 2 points and working out the gradient of the line here, which represents acceleration on a velocity time graph, I've calculated the acceleration here is minus 1.5 meters per second squared, but that's not the final answer. The question said, what is the deceleration? So the deceleration will be 1.5 meters per second squared, because the word deceleration represents the minus here.